Hi, this is Sid back with another video, and this is the continuation of offensive hacking and exploitation. In this video we will start exploiting NFTP client. Okay, let's begin. Okay, some closing thoughts from part 1. In part 1, when we do the basic buffer overflow, we can override the return address. Also, I told you that EIP point to the next instruction and ESP point to the top of the stack. Now let's simulate our previous attack. This is the buffer in well and good condition. After buffer overflow, the stack look like this. The return address is override by all A's, and when the function returns, the return address put into EIP and then executed. At this moment, when return address popped from the stack, the ESP point at this location. Okay, let's design our crafted input. So this is our well and good stack. So what we will going to do, first we filled the buffer and EBP value with all A's. After that, at the location of return address, we filled with some addresses. Next, we will fill with nope instruction. So what is nope instruction? Nope instruction is the instruction which only consumes the CPU cycle and do nothing. And after that, we put the shellcode here and then we filled with some nopes. Now, so what will be the address we put in the location of return address? It will be the address of the shellcode. Now, for smoother landing, we can insert the return address at any location within the nope instruction before the shellcode. So first, our primary task is we need to find the size of the buffer as well as EBP value. Okay, let's jump to our lab machine and create the crafted input. Okay, we are in our demo machine and we can reach the attacker machine by pinging it. 180. This is the attacker IP address. Okay, now get back to our attacker machine. Let's create the malicious server. .py. Okay, first we need to import the socket. Let's define the IP address. So why it is 000, we need to bind to every available interface. Now the port number, let's choose the port number 5000. Let's define this kind of socket. Socket dot AF underscore inet. AF inet for IPv4 connection because we are dealing with IPv4, and sock underscore stream because we need a TCP socket. Okay, let's bind our socket to our interface. Now we need to give the IP and port number in a tuple. Okay, we don't need to handle too many connections, so let's define only one connection using listen. At the same time, only our server can handle only one client. Okay, now let accept the connection from client. It will be the no client IP and client port within a tuple. This will be in the while loop. Now we need to copy some code from previous exploit. Let me open that. Now when the client is connected to our server, now this code will be the responsible to welcome the client. Let me copy this. Paste it here. Now we need to change something. This all con will be our client. Do some Vim magic. Con will be replaced with client. Now we need to change two more thing. ADDR will be our client IP address. We need not to worry about EIP and NOP instruction for now. Let me delete this. Let's define our buff variable. This will be our evil buffer. Okay, let me define it here. A, let's say 5000 of A. This will be within the code. Sorry for that. We need to insert one more line. Now our exploit is ready. Let me save it and make the server executable. Now let's run the server. Now let's go back to our victim machine. Open NFTP. Put the attacker IP address. And the port number will be 5000. Now as soon as I hit the enter key, the program crash and the client receives some junk from the server. Okay, let me exit this and let's get back to our attacker OS, and you can see our exploit is sent and the client was connected. Let me exit this. Now for low-level inspection, now we need to run within a debugger, which will be the immunity. Let me open it within the immunity. Attach it. and this is the process. Now this is the register window, and this is the stack, and this is the NFTP assembly. Okay, now let's run it. Let's get back to our attacker OS, run our evil server. Now our server is also running. Let's get back to our victim machine, open the malicious link. Now you can see our return address is override by AAAA, and now EIP is pointing to that return address. So it is also AAAA 4141 is hex code of A. And you can see ESP also pointing to all A. Okay, let me restart the program. Now we will going to find out what is the size of the buffer. So how can we do that? Let's get back to our attacker machine. Now we are going to use a tool called pattern.create. Let me find that. Now we can find it within this directory. Let me go to that directory. Let's create a pattern. Now let's say 6000 of the pattern. Let me create the pattern. Now our pattern is created. Let me copy this. Open another terminal. Open our exploit code. Now instead of A, we will send our pattern. Okay, this pattern will help us to find out where the EIP will overwrite. Paste it here. Now let me save it. Run the server. Now our server is running. Let's get back to our victim machine. Restart the program. Let's start the program. Open the malicious link again. Just hit and enter. Now let me find the offset where EIP is getting overwritten. Okay, how can we do that? Let me go to our victim machine. Now here we use another tool called pattern.offset, pattern_offset. So first will be 46, 32, 68, 62 to 68. Now let's find out the ESP. This will be 68 46 33. 68 46 33 68. Now as expected, ESP point after 4 byte. Okay, let's modify our exploit code. Delete the buffer. Now let's find out our hypothesis is right. First 4116 byte will be the A. After that EIP will be overwritten. Then after that ESP will pointing to, let's say 3000 of them. Now send EIP and ESP also. Let me save it, run the server and get back to our victim machine. Okay, restart the program. Let's run the program. Open the malicious link 192.168.23.180 and 5000 port. Now hit enter. Now you can find out our hypothesis is right. Now the EIP is overwritten by BBBB and ESP is pointing to all C's. Okay, now that's it for this video. In next video I will do the rest of the exploitation. If you really like this video, give me a thumbs up, share among your friends, and I really appreciate your comment.